So after our battery charging, we'll get to the motor. So we will do a motor idling test right now. So this is a 1000 kV volt motor. So this test is basically to check that how much time the motor runs, but just not only runs but runs with a bit of a load on idle, to just check that how much the battery can supply. So we'll just connect all of these parts quickly. So first we take this part. This all comes with the motor. So in order to connect the fan to the motor, we'll first put this screw on top of it. Then we will use this bracket. As you can see, it will be placed here. Sorry, I think so this will be something like this, right? This is correct? No, this is not correct. This will be correct. Okay, and once this is placed, we will place this on top, and then finally we will place this screw on top of this. So it's like a sandwich. So we'll just tighten this up quickly. Yep, everything has to be centered in. Yeah, this thing doesn't look that it is centered. Is it centered? Yep, it does look like it is centered. Okay, we'll try to tighten this up. We will require an Allen key to tighten this thing up. So we have connected the motor to the fan, and after connecting the motor to the fan, what are the parts that we will require? So this is a part that we will require. This is a servo motor tester. We'll require an ESC, and we'll require the battery, of course. Also, to keep a check on the voltage on the battery, the voltage drop and everything, we will require a voltage tester. So we'll quickly go ahead and connect all of these things together. So as you can see, this thing, the ESC is the main component. So this we will connect quickly with the motor. So this is a 30 ampere ESC, Simon 30 ampere ESC. Since the motor, so the ESC is directly proportional to the battery and the motor. Since the motor maximum draw is about 15 amperes to 20 amperes, fluctuation draw of 20 amperes, technically this should be able to handle the motor. But I had a previous ESC and that was heating up. So this is a new ESC that I have bought. So we'll just check this out and we will see. So these three wires will be aligned like this, and these three wires will be aligned like this, and we will put this here. So the yellow one always stays in the middle, and we can interchange the black and the red to to go into opposite polarity. Suppose if the motor is rotating like this in the clockwise direction, it will start rotating like this in the anti-clockwise direction by changing the black and the red wire. So now we'll connect all of this quickly. I'll just show you how this is connected. We'll put this here. So these three wires will go in here. First put in the yellow so that confusion is avoided. Then we put in the black at the last end, and then we put in the red. So all of this is connected here. Okay. Then we go ahead with the servo. As you can see, this is the voltage tester. Sorry, not the servo, this is the voltage tester. We will first check the battery voltage that we are dealing with. So we'll just quickly give this a check. It's a bit difficult recording and shooting also and doing things also. So we have to put it on the opposite side. Okay, this side is not showing any readings. This side should. It shows 8.4 volts, 4.2 volts. So that means it is fully charged. Okay, so this is connected finally. Okay, so this will give us a constant check. So this is a BEC circuit. This will be required when we have the transmitter, but right now we are not using the transmitter. So this is done on this side, and okay, So we'll connect this final connection to this. Okay, red to red, black to black, so that any confusion is avoided. Okay, this is a bit, see, there could be a bit of a sparking. Yep, this is connected finally, and I just forgot that this thing has to be connected to the servo motor tester, as we can see it here. So sorry, I think so this thing has to be connected. Yeah, so I'm just forgetting things nowadays, I don't know. Yeah, this thing has to be connected, since the BAC socket has to be connected to the motor. And since the BAC circuit will be connected to the receiver, so that is why this has to be connected. We can still connect this to the voltage tester and keep a constant check on the voltage. The motor is primed, the motor is ready, and we will just connect this quickly so that the voltage is constantly kept in check, so that we can get a review on how much is the draw. So we'll just check this M1. It's not that hot right now, and we'll just go ahead and check the motor. Okay, what is happening? Okay, we are having an error on the motor. Okay, this is fine. Okay, I think so just keeping it on the ground is the problem. So that is the issue. So we're just using it at very low RPM right now. This is shutting it down. Okay, so this is just a loiter mode, just to check whether this thing will be rotating or not. Yep, it is, and you can see the draw on there. Wow, the wind also is really good. It's pretty hot right now, but this thing is giving a good cooling effect. So on idle thrust, we are running it an idle thrust right now. The draw is not a lot, so it's quite fine. Let's see if we actually increase the throttle, whether it's a good idea or not. Let's just check it out. I think so it's not a good idea. Yep, that is thrust. That was my thigh where it's kept. That is why this is that. It's literally ready to take off. Run it for some time and we'll just check. So yeah, this is just an idle test. I think so this motor and with this combination will run for quite some time. As you can see, after running it for about a minute or two, the voltage has just dropped from 0.02 on idle voltages. So I think so this combination will actually do well. This is what I feel like it. Let's see. After doing some tests, actually after making my rig, I will tell you about how much time this thing actually run. So first let me just make my rig, and then I will inform you all about what is the output of my tests. Okay, till then you can have a great day. Crazy things. So yeah, after running it for a good 3-4 minutes, the voltage drop is not a lot, and it's pretty well. The ESC gets a bit hot, not a lot, but this will only be coming to know with time about how well this ESC handles. This is the cheapest ESC actually on the market, but still it is the best ESC that you can get. Always cheap doesn't mean that it is bad. In the price range, this is the best that we can get, but obviously there can be better ones that we could be getting. So the other best thing is that even so, this thing actually rotates. The body rotates. It's not that only this part rotates. The entire body rotates. But since this thing is actually not, fixed, the body does not rotate. So that's one good thing about it. So let's see. Let's put in all of this thing into the aircraft, and let's test it out and see how does it actually work. I would require 4 screws here, as you can see. Once I get that, I'll make my rig and we'll do a thrust test properly to check how much thrust does this motor and this propeller combination actually develop. So once we get all of those values, we will go ahead and install it into the aircraft with the transmitter and the receiver. This is the voltages that is still remaining. I'll run it for a bit more time just to drain out a bit of the battery so that I can keep it in storage. And yeah, so thank you for watching and have a great day.